Hello everyone, here is a quick video on how to find domains. So there are three possible ways that you might be asked to find a domain. You are either given ordered pairs, okay, so you may have, let's say, 1, 2, 3, 4, 7, 9, and so forth. And then you are asked to find the domain. And let's say also range in this case. So the domain would be the set of just the x values. So this would be 1, 3, 7. And let's say if we had another one, let's say 10 and -1 or something like that. And then here we would just say 10. Okay, and the range would be just the y values. So this would be 2, 4, 9, and -1. Okay. Another way you might be asked to find a domain is given a graph, but I'll do the graph later. Let's talk about if you're given a function. So let's say you have a function 2x minus 9, or the function might look, so the function might be like this, linear functions, right? X or something like x minus 1,000 or something like that, a linear function like this. Or it might be in this format, cube root of something, x plus 9, or fifth root of something, 2x minus 4, as long as the index is odd, okay? As long as the index is odd, alright? And then, what other option? So these two options, if it's a linear function, if you have an index that's odd, the domain and the range will always be from -infinity to +infinity, from -infinity to +infinity. Any of these. If it's a linear function, if it has a odd index, then the domain and range will always be -infinity to +infinity. If you have other functions other than these two, then we take a different approach. So let's say the function was f of x equals, let's say, square root of 4x plus 1 or something like this. Or it could be fourth root of something, 2x minus 1. Okay, it could be 12th root of something, x plus 1. As long as the index is even, okay, as long as the index, the little number right here, is even, all right, the approach we'll take would be, we'll take what's inside. So let's take the first one. It will be 4x plus 1, and we set it greater than or equal to 0, and then you solve it for x. So we subtract 1 from here, from both sides. This would give you 4x greater than or equal to -1, and solve it for x. Okay, so this cancels out. You get x greater than or equal to -1/4. So this is algebraic form. So if we have to write it in set built-in notation, it would be the domain, okay, would be for all values of x such that x is greater than or equal to -1/4. Okay, sorry you can't see that. Okay, and we can also write it as interval notation. So it would be, another way of writing this would be bracket -1/4 and then all the way to infinity. So this is set built-in notation, and this would be interval notation. Okay, and any of these you will take the same approach to find the domain. Okay, and another one, let's say you have a function where it's f of x equals, let's say 2 over x plus 1 or something. As long as it's in this format, p over q, as long as it's in that format, p over q, we solve the denominator. We say that x plus 1 cannot equal to 0. Basically, the denominator cannot equal to 0. So we will get that x cannot equal to -1, basically if you subtract 1 from both sides. It can be anything, but not that value. So the domain then would be that from -infinity to -1 unioned with, and then it would be from -1 to infinity. Or in set builder notation, we can write it as for all values of x such that x cannot equal to -1. It can be anything, but for those two cases, right? So you have this way of finding a domain. You're given ordered pairs. This is how you find the domain. You're given this type of function, right? Any linear function or any with any square root or cube root or fifth root index odd, right? All of them will have a domain basically from -infinity to +infinity. However, if the index is even, square root or fourth root or 12th root or any even root that is even, then the approach you take is you take what's inside, set it greater than or equal to 0, solve it for x. So basically that's what you have. This is algebraic form. That value, so x will be less than or greater than whatever it might be, and that would be your domain. And when you write the answer, you can write it as interval notation. Oh, sorry, this is set builder notation. Okay, and this is the interval notation. Okay, so this is the set builder notation, and this is the interval notation. Okay, so these are the cases that you might see, or you might be asked to find the domain. And the last case you might be asked to find the domain is given a graph. All right. Okay, so you have, let's say, a function like this. Let's say this is x squared, right? F of x equals x squared, produce a parabola. And when you're asked to find the domain, all you care is the x values. Okay, the x values here, right? So this arrow, it just keeps on going all the way to -infinity on the x side and all the way to +infinity on the x side here. So the domain would be from -infinity all the way to +infinity. If this question you were asked to find the range for this question, the range again is just the y value, so it would be where it starts. Let's say here this is 0, so that would be from 0 all the way to infinity, because it goes through 0, so 0 is included. So it would be from 0 all the way to infinity, because the y is going all the way to infinity, and here for the y is -infinity. Okay, please comment, subscribe, and like. If you have any question, please ask. Thank you.